SMED, single minute exchange of die. What is that? This is a picture of a SMED setup time reduction training model that I designed and made myself to use whenever I'm training people in the techniques and methods of SMED. SMED stands for single minute exchange of dies, which was developed by a Japanese engineer called Shigeo Shingo. This picture shows the model in the initial configuration, and it is with no modifications or improvements made. Changeover time at this stage is between 20 and 30 minutes. This is a picture to the one to the right where it says after is the setup reduction that I've designed myself, where it's all the modifications have been made and the setup time reduction has now been reduced to where it now is only 20 to 30 seconds long. The before picture shows the model in the initial configuration, again with all the inefficiencies. Then the after picture shows the model in the final configuration with all the modifications and improvement made. There are 5 principles towards SMED, and they are preparation of operations. Essentially, this is all about having everything involved in the changeover 5S. Number 2, elimination of unnecessary settings and adjustments. This is where you are using, for example, calibrated gauges and a system that is called least common multiple. I only have 15 minutes of time on here, so I can't go too deep into each principle. Interview me for a job and I can go as deep into details as you want about SMED. Number 3, rationalization of handling and tightening means. This is achieved by tool unification, tool elimination, or method substitution. Number 4, synchronization of tasks. This is where you plan the work task to happen as much as possible in parallel with other paths. Number 5, standardization. Everything is documented as standard with a preparation and post-operation checklist and changeover procedure. There are 5 stages to running a SMED event training workshop. Number 1, observe, record the entire changeover using a video camcorder. Number 2, analyze. Review the recording and using some time analysis from fill out changeover work elements or tasks, noting each element as whether it was an internal or external element. Number 3, improve. Convene with the people that were involved with the changeover event on how every element in some way can be improved. Number 4, implement, plan and implement those suggestions and ideas. Number 5, standardize. Develop your pre and post operational checklist and changeover procedure. This is my own personal nostalgia with the evolution of SMED recorded media technologies. My first SMED event was in 1999. The camcorder of choice available back then was a Magnavox recorder. Depending on how you set up the quality, it could record up to like 4 to 6 hours. Very time-consuming reviewing the tape with the analysis with the old VHS machines that they had back then. Hitachi later came out with a disc camcorder DVD that could record up to 4 hours directly on the DVD disc, and it could utilize both sides of the disc. JVC came up with the world's first hard drive camcorder that could record up to 24 hours or more, but was not PC friendly. So you had to convert the files afterwards, and it took hours to do. Sony broke the mode when they came out with the first solid drive camcorder, which could record up to 36 hours and beyond. It was PC friendly, very WMV and PC4 friendly. This is my own changeover analysis worksheet with population charts showing what parts of the changeover took the amounts of time. This is my time analysis work from which I created a pie chart to show graphically where all the elements of the changeover stack up. Some changeovers can, by their nature, be a beast to take so long. It's always a good idea to have a plan in place that shows the timeline of completion. I developed this to track the changeover and setup time plan action. Two important critical documents that come out of a SMED workshop of a SMED event is the preparation and post-operational checklist and a changeover procedure. These should be two sets of documents. One that is a preparation and post-operation checklist for the operators and a changeover procedure for them so that they can prepare all the materials, parts, and documents that are required for the changeover procedure. And also another document, the same preparation and post-operational checklist for the maintenance and the changeover procedure for them or whoever will do the changeover for them. The reason why this is so critical is many times I've done SMED events and only to find out that we're most of the time is searching for things like an operator pendant for the overhead crane, or we find out that there's a flat battery or the forklift truck is out of gas. This is an example of my changeover preparation checklist. This is an example of a changeover procedure document, and this particular example is the most advanced, most long, and most detailed and involved changeover that I have ever done in my career to date. If you have a high mix of changeover, it's a good idea to figure out those combinations of modes or tool types, such as whether it's a left hand, right hand, front, back, US version, UK version, whatever it may be, to have a register of a changeover matrix. SMED is the nuts and bolts of a quick changeover or setup time reduction, but an intimate part of SMED is the administration of how the changeovers are scheduled in a production run order, albeit weekly or monthly. This is known as level loading, or in the Japanese lean term, hajunka. In lean manufacturing, hajunka is the practice of smoothing out the type and quantity of production runs over a fixed period of time. Instead of producing in large infrequent batches, it involves producing at a steady, predictable rate to enhance or to reduce variability, mura, and eliminate waste, muda, and improve the overall efficiency of the changeover. Organizing your production changeover using leveled loading approach requires changeovers to be very efficient with the least amount of time to perform them. During a SMED event, you document each element of the changeover as to whether it was an internal element or an external element or task. Internal meaning any element or task that can only be performed while the machine is stopped or idle. An external element or task meaning that it's a task or an element that can be performed while the machine is running, either before or after the changeover. One of the greatest challenges of SMED is to see whether somehow you can convert an internal element to an external element. There are two well-known examples of this, and that is tires of a race car. The tires and wheels get quite hot as the race car races around the track several times, and these tires stick to the racetrack surface because of this fact. This is the internal element. So the new set of wheels with their tires are actually kept in an oven by the pit crew to pre-warm the new tires so that they are already at the right temperature for the temperature, and the tires are all ready to go with the stickiness. This is the external element. And the other well-known example of converting an internal element to an external element is pre-cooling or preheating a tool or mode in preparation for the changeover. So you don't have to wait for the machine itself, to heat up or cool down the tool or the mode, which is an internal operation which could waste time before the machine can start back up. This is another example of converting an internal element to an external element. Here I have designed the machine in such a way that the interchangeable parts can be swapped out from the machine while it is still running by having a cross-sliding external parts magazine. This is my little PowerPoint presentation animation slide that I take it out of my slide training. This is an example of a tool elimination I came up with using toggle clamps to hold down this ultrasonic welding tool nest, thus eliminating the use of fasteners and the tool. It's been said that tools and fasteners are the enemy of SMED. This is an example of eliminating the use of both in the injection molding machine, where we installed a magnetic holding platen to both the stationary and the moving platens. To me, it doesn't matter. Time is time. I performed so many SMED events where the changeover is either 5 hours or can be as less as 5 minutes. Changeover and setup time reduction is always possible. In this example, I was using when I was working for Alfmeier, and here is a demonstration of using gravity to hang your interchangeable tool in. Before, these SMED tools were used and kept inside a box underneath the machine, which was very inefficient. This is my own design of a mobile portable SMED toolboard using Bosch aluminum profile and of course polypropylene plastic pegboard. I used MS Visio to design this. Here I designed this mobile pegboard to utilize both sides at the front and the back for storage. This is a slitter cutting tool storage platform that I designed and built for quick changeover of both the male and female knives. The rack has 4 shelves, each storing 5 knives. The 2 upper shelves are either new or refurbished knives, and the lower 2 shelves are to be repaired storage. I designed this again using MS Visio. This is the finished deal. I later storage post these for the next. This is my own design SMED training kit that I designed and made myself. The progressive improvement is made by my SMED training attendees with the changeover. The current state, which is full of all manner of inefficiency, takes anywhere between 20 and 30 minutes. But with the progressive improvements that the attendees make, they predictably reduce the changeover time to 30 seconds. Thank you for watching. This is a series of videos that I will be posting each week to illustrate my experience, knowledge, skills, certifications, and qualifications, and what I can bring to bear into your organization. Please contact me at my email address at fred@fredwebberking.com. My phone number is area code 864-283-1736. And of course, please do visit my online career portfolio at fredwebberking.com. Thank you again. I am Fred Webberking. Bye for now.